Anji? Can you see slides?
Yes, sir.
Okay. Okay, Bismillahirrahmanirrahim. As you mentioned that we were solving a numerical of the cross drainage works, and in this numerical we have covered all parts. Only the left is how to design the transitions. If you remember, the length of the transitions we have already designed. The length of the contraction transition was 10 meters, and the length of the expansion transition we calculated as 15 meter. And you know, those lengths are computed from the value of the splay. And splay normally it is used as 1 in 2, 2 in 1 for, or 1 in 2 for the contraction transition, and 1 in 3 for the expansion transition. And so anyway, so let us first come to the contraction transition. And for contraction transition, what we have, this data is available, that the width of the flumed trough, that is the 10 meter, normal width of bottom width of the channel is 20 meter, and the length of the transition, which is from here to here, it is 10 meter. And if you'll put these values in this equation, which contains x, so you will get finally this equation bx. It means that the width of the transition at any distance x from the flumed section. So this would be the final equation, and then what we can do, we can make a table like that, where these are the values of the x, maybe at an interval of 2 meter, and this is the bx, which is this equation 2000 over 200 minus 10x, and then you can compute their values. And you know, at 10 meter length of the transition, the value should be 20 meter, which we are getting. So it means in this way we have designed the contraction transition. So if you have any questions in it. Is it clear? Okay, now we have to design the expansion transition. So this is the expansion transition. The length we have already computed as 15 meters. And now this is the equation for the bx, the width of the transition at any distance x, which is measured from the flumed section. And if you will put these values, this say you after simplification, the equation would be this 3000 over 300 minus 10x. And similarly, you can make a table in which you can compute the values at an interval of meters, and the last value for the 15 meter length, and at an x value 15 meter, you know, what should be the value of the bx? It should be 20 meters, same as the bottom width of the canal. And so bx have been computed, and once these are computed, it means now we have the values, and actually we have designed this transition. Only the fifth step, that is the design of the trough. So a concrete trough we have to design. And you know, the total width of the trough is 10 meter, and that we have waterway length is the 10 meter. And because how much is the flume width of the canal? How much is the flumed width of the canal, which is passing over the drainage? So that was 10 meter. So 50% was the fluming ratio. So there 5 meter and 5 meter, we have made 2 compartments. The reason is, as for this any 5 meter, we can provide a bridge for the road. And you know, the depth of flow in the trough, as you remember, was 1.5 meter. So it is the 1.5 meter and the 0.6 meter. We will leave the free boat. So the total depth would be 2.1 meter. All right, of this trough under the this slab. And we have to provide these retaining walls. These walls will be designed as retaining walls. Normally the thickness is kept as 0.4 meter. And also the thickness of this retaining wall is 0.4 meter. Whereas the middle wall, its thickness is smaller, that is 0.3 meter, means roughly 1 foot. And the slab thickness is 0.4 meter. And these slabs are designed by considering the weight of the water and the self weight of the structure. So this is all about the design of the trough. Is it all right? And what you can see, these black. Can anyone tell me? These are the piers. Okay, these are the piers, on which this trough is testing. And you know, you have to also mention various levels. So this level is to 10 meter, which is the high flood level, which is given. And then this is to 11.6 meter, because this level is given. This is, I think, 212 meter. So this 212 meter, and then 0.4 meter is the thickness. So this should be 211.6 meter. This is 212 meter. And similarly, you can compute the level of the soffit of the slab. It is 214.1 meter. So this all is the design. And the water level in the trough would be, or the full supply level would be 213.5 meter. And when this is the plan, and this is the section of the type 1 aqueduct. So in the plan, you can clearly see, so this is the contraction transition, this is expansion transition, and this is the direction of flow. And these are the piers, which you can see in plan. And this is the rectangular trough in 2 compartments. One is this and another is that. And if you will take a section here, so this one is the section. These 2 are the abutments which are given at these locations, and these are the piers. And with that, we have finished this chapter. Okay, that's fine. Do you have any questions? Shall we move ahead?
Yes, sir.
Yes, sir.
Okay, there are only 30 people. Why are they enjoying the weather? Okay.
Yes, sir. Very good.
But you know. Okay, let's start our chapter number 7. And it is lecture 7, but actually chapter 7. The name of the chapter 7 is waterlogging and salinity. What is waterlogging? Waterlogging means rise of water table. Is called waterlogging. Not all rise of the water table are called waterlogging. So an agricultural land is said to be waterlogged when its productivity gets affected by high water table. If the water table is risen and the crops which are grown on the agricultural land, and if their productivity is affected, that is called as waterlogged soil. Nutrients like nitrates are required by the plants, which are produced by bacteria. Okay. And they require oxygen. Bacteria require oxygen for survival. Waterlogging kills these bacteria. So once the water remains stayed for a long time in soil, then the bacteria, they cannot get oxygen, and the bacteria they killed, and nutrients which are nitrates are not generated, and then the plant also wilts, or its productivity is affected. Productivity gets affected when root zone of plants get flooded with water for a long time. Now you see this is the aeration zone of the soil, and this is the root zone. This is a plant, and here in this root zone, if the water table comes here and disturb, then water will remain for a long time in the root zone of the crops or of the plants, and that is called as water logging. So in this figure, you can see that this is the ground level, and this one is the root zone of the crops, and this is the groundwater table. So if you see here, this is the water table, and this is the root zone of the crops. So it is coming very close, and this may cause the water logged area. So this area is water logged area. So as per WAPDA criteria, what the WAPDA says, the land having depth to water table less than 3 meters is classified as waterlogged. If the water table is available at a depth lesser than 3 meter, 3 मीटर कितने होते हैं? 10 feet roughly. अगर 10 मीटर पे 10 फुट पे आ जाए our ground water table, then as per WAPDA criteria, it is waterlogged soil or waterlogged land. Further, WAPDA classified it in two classes. That is the severely waterlogged and less severely waterlogged. Severely waterlogged is that when the water table comes too close to the surface. How close? From 0 to 1.5 meter from the ground surface. 1.5 meter पे आ जाए. 1.5 meter means roughly 3 foot. And नहीं, 3 से ज़्यादा हो गया, 5 feet. And less severely waterlogged क्या है? If our water table depth is from 1.5 meter to 3 meter. So this is a table which gives the data of our 4 provinces, their lands, and water depth below the surface for 0 to 5 feet, 5 to 10 feet, and 0 to 10 feet means 1 plus 2 in the third column. So 0 to 5 feet means this land is severely waterlogged or simply waterlogged. क्या जी?
Severely waterlogged.
Severely waterlogged, बहुत ही water table ऊपर आ गया है. And this is less severely waterlogged soil from 5 to 10 feet. या यहाँ पे क्या था? 1.5 to 3 meter. Okay, let us see in Punjab. The severely waterlogged area is 1.9 million acres. Okay, whereas less severely जो है agricultural land in Punjab is 7.52 million acres. The total is 9.42 million acres. Whereas in Sindh, it is 3.13 million acres. Severely waterlogged area, and less severely waterlogged area is 8.54, and the total is 11.67. In NWFP, it is very little, 0.09 and 0.33. The total area is 0.42. And in Balochistan is also very less, 0.14 and 0.24, and that is 0.3 million acres. If you will see this table, which province which province has the maximum, waterlogged area? Which one it is? Sindh province. What is the reason? The land is relatively more flat, and the soil, grain size is relatively finer, and moreover, they use a lot of irrigation water, and that's why the Sindh area is waterlogged at number 1. Anyway, the total waterlogged area in Pakistan, severely waterlogged area, is 5.26 million acres, and less severely waterlogged area is 16.6 million acres, and the total waterlogged area is 21.89 million acres. Now, causes of waterlogging. These are the 8 causes of waterlogging. Number 1, first cause is over and intensive irrigation. Waterlogging mainly is developed due to irrigation. That's why irrigation projects are incomplete without drainage project. So if you are supplying somewhere irrigation, maybe surface irrigation through canal network, then we must have to also design the drainage network. As what we are doing in irrigation, we are supplying more water, more than the natural water which was infiltrating in the lands. So as we are supplying more water, what it has to do, it has to raise the water table, and ultimately it will cause waterlogging. And that's why whenever we develop irrigation projects, so at the same time we must design and develop drainage projects, because the excess water, irrigation water, which we supply to lands must be taken away from the land. Then those lands will remain away from the waterlogging. The second is seepage of water from adjoining highlands. Actually, these are explained in next slides. Here I will just give you the names. Number 3, seepage of water through canals. The next is impervious obstruction. The next is inadequate natural drainage, inadequate surface drainage, and the excessive rain, and the irregular or flat topography, and these are explained here. Over irrigation, policy of intensive irrigation increases water table. As I mentioned you, if we will doing the irrigation by flooding and by a lot of water we will apply, definitely that too much water is not required by the root zone of the crops. What happens that with passage of time it infiltrates into the ground and raises the water table. To avoid this, policy of extensive irrigation should be used. So policy of extensive irrigation should be avoided. So number 2, seepage of water from adjoining highlands. So there are highlands, okay, and there is maybe a flat land. So whenever there would be rainfall, the surface runoff will generate from the highlands and it will come to the flatlands. So, and when the water will stay for a long time on flatlands, of course it has to infiltrate, and once it will infiltrate, so it will raise the water table, and then it may cause water logging. The third is you can also understand with this diagram. For example, this is a flat land, and this is here, this is flat land, and here this is a sloping land. Whenever there is rainfall, the water will come here, and here water will corresponding here, and that will infiltrate into the ground, and then the water table, if it was here, it will come up, okay, and may cause waterlogging. Why we say waterlogging? Then this water table will disturb the growth of the plants and crops. Okay, number 3, seepage of water through canals. And you know very well that if the canals are, which one? Unlined, then there is seepage from here, from the bed of the canal and from the sides. And so you know, in Pakistan, how much is the length of the canals? 69,000 kilometers. So number 4 is the impervious obstruction. If there is some impervious obstruction, you know, below the surface, means some impermeable layer, then water doesn't percolate down, and then it comes on the surface. And its example is like this is our land, and here there is an impermeable layer. So whenever there would be rainfall, then what will happen? Due to this impermeable layer, it cannot go down, and the water table has to rise. So it will cause the water logging. And you know, this is the root zone, less than the root zone, this depth will become, and it will affect the crop development. Number 5 is the inadequate natural drainage. So some soils, they have less permeable substrata below pervious soil, and we're not able to drain water deep into ground, causes high water table. It is very similar as we discussed number 4. And number 6, inadequate surface drainage. And if we do not have proper surface drainage, then what happens? The water will stay on the surface and then ultimately will infiltrate into the ground, and which will rise the water table. Excessive rain. You know that whenever there is an excessive rain, it causes the ponding of water on the surface. I mean, the surface runoff is generated, and then the water infiltrates into the ground. And particularly when there is less intensity rainfalls for longer durations, so whole of the water, it doesn't cause flooding, but the whole rainwater then infiltrates into the ground, and that raises the water table, and that rise of water table is called as water logging. And number 8 is irregular or flat topography. You know, in steep terrain, water is drained quickly, but if the terrain is is relatively flat, so then water doesn't move very quickly on the surface, and ultimately it infiltrates into the ground and raises the water table. So these are the main causes of water logging. Now we have to discuss what are the effects of water logging. What is the first effect of water logging? You know, once the water stays in the root zone of the crops, so it kills bacteria, which produces nitrates and nutrients for the crops. The second, it causes loss in crop yield. Crop yield is reduced a lot. Number 3, water logging leads salinity. So these salts, they come on the surface. And next is normal cultivation operation cannot be carried out easily in wet soil. You know, when it is wet, it is difficult to plowing, and you know, to preparing it for the cultivation. So because of the standing water in the lands. The next is certain water-loving plants like grasses, weeds. They grow automatically at a very fast rate in waterlogged lands and affects the growth of crops because the water is available. So other these weeds and grasses, they grow very quickly and they affect also the yield of the crops. The next is a spread of mosquitoes and malaria. If this is also a result of waterlogging and destruction of roads, if the soil is waterlogged, of course, the bearing capacity of these grade and subgrade that is reduced and it damages the roads. Next is causing dampness in buildings. Okay, appearance of salt on surface, weakness in plaster, and produces ugly poop spots. So that is also the dampness, overall dampness in the building it may cause. And if salty soil is used to make bricks, salt appears on the wall surface because that bricks contains a lot of salt. So is it clear? Jaji, what are the effects of waterlogging? Now, remedial measures of waterlogging. What we can do? Number one, provision of efficient drainage system. When you are providing irrigation, you also provide an drainage system. The second is lining of canals and water courses. So actually this canal network including all type of canals and water courses. If these are not lined, they are major source of seepage of water into the ground and rise of water table other than the irrigation. Number three is reducing the intensity of irrigation. Don't use too much water per acre. Number four, by introducing crop rotation. Number five, optimum use of water. What is optimum use of water? For any crop, the productivity would be maximum on this amount of water. And if this is the productivity or the yield of the crop, then only use this much water. This may be in this way, opposite to that, like this. So this is the optimum yield. If you will use more water or less water, in both cases, this is fine. So this is how you can do. Number six is providing intercepting drains. So intercept that we will just discuss. And number seven, improving natural drainage of area. And number eight, introducing to lift irrigation. Lift irrigation means by pumping. Now these all are explained here. Provision of efficient drainage system. A good drainage system should be provided, means surface drainage and subsurface drainage, both. If we are providing a surface drainage system and subsurface drainage system, then it is easier to control the waterlogging. Number two, lining of canals and water courses. So it reduces seepage of water and ultimately the waterlogging. Number three, reducing the intensity of irrigation. Intensity of irrigation should be reduced. And number four, by introducing crop rotation. Certain crops require more water and other requires less. So rotation of crops avoid high water table. I mean, those crops which requires more water, don't grow them continuously. So there should be crop rotation. Number five, optimum use of water. Certain fixed amount of irrigation water gives best results. Less than that and more than that reduces yield, as I showed you the graph. Okay, so crop yield is reduced, and so we have only to use that optimum water, neither more than that water nor less. Number 6, providing intercepting drain. What is an intercepting drain? For example, if we have a slope here and there is a flat land, as we discussed earlier, suppose this is a sloping area and this is a flat land. So this water will come here on this flat surface. So we have to provide here a drain, which is called as intercepting drain. So whatever the water will come, that will come in this, and it will be intercepted and will move down in this direction. Okay. Number 7, improving natural drainage of the area. So we have to reduce percolation of water, as the water should not stand over the surface. And number 8, introducing to lift irrigation. It helps lowering of the water table once we will extract water from the ground. And this is called as vertical drainage. तो पहले हमने डिस्कस किया था ना horizontal drainage. This is called as horizontal drainage. Horizontal drainage means provide surface drainage and subsurface drainage. Vertical drainage means provide pumping or lift irrigation. Now this is a photograph which shows the Dutch windmills pumping water from waterlogged soil. So this is waterlogged soil and they are pumping water and throwing in this channel. Now the land drainage. So there are two main types of the land drainage. Number 1 is the surface drainage and number 2 is the subsurface drainage. Its another name is tile drainage. Now we would like to discuss the both separately. Let us, number 1 is the surface drainage. What is the surface drainage? Is required for the removal of excess water by using and construction of open ditches. So open ditches, yeah, drains, those are called as field drains, and also by making land grading, so giving some slope towards those ditches and relevant structures. So this all is called as the surface drainage. So in the surface drainage, what we have to do, we provide the ditches and drains. So those drains, whenever there is a rainfall or excessive irrigation, so that water they receive, and then the water moves in the downstream direction. And these drains, what is the name in Urdu of these drains? Who will tell me? Surface drains. Who will tell me the name in Urdu? No one is hearing. What is the name of surface drains in Urdu?
No idea, sir.
This is very easy. Have you heard same nala?
Yes, sir.
Same nala. What we call in Urdu to waterlogging? Huh?
Seam, sir. Seam throat.
Same, है ना? Okay. So ये same नाले, and you might have seen the same nalas. The main purpose of the same nalas is what is that I would like to show you here. Now this one is a canal, है ना? and these are the embankments of the canal. This is a canal, and this is basically a drain, surface drain, and this hole is called as surface drainage. So whenever there is irrigation or rainfall, that water goes from the surface in this drain. Okay, that water which seeps inside, which infiltrates, and this is the water table, and the water table is being lowered by these drains. So these drains are much deep enough, so the water table is lowered through these surface drains, and these surface drains we provide in areas where the permeability of this material is enough as the water can infiltrate. But you know, in some areas these are highly impermeable material is available, and then water does not infiltrate much into the ground. Anyway, what is the name of this drain in Urdu? इसको क्या कहते हैं?
Same nala.
This is same nala, and this one is the canal. What we call it in Urdu to canal?
Nahr.
Nahr. Okay. So this is same nala, a drain. Okay. Now please let me know what is the function of canal, about the level of the canal. Where do we provide canals? In the area. Or where do we keep the full supply level? ये full supply level कहाँ रखते हैं canal का?
2 feet above ground.
Yes, above ground. Why?
सर above होगा तो अगर gravity flow के मतलब
Yes, gravity flow होगा. What about this drain? Where do we provide, by the way, drains? यहाँ पे जो ये canal है वो हम कहाँ provide करते हैं? Usually we try to provide those canals where? कहाँ provide करते हैं?
below the water table.
और नहीं यार, on ridges. टोपोग्राफी, किस टोपोग्राफी पे हम कैनाल कोशिश करते हैं कि अलाइन की जाएं? ओवर द पीक्स इन द एरिया, है ना? ये जो हमारे फ्लैट लैंड है ना, ये फ्लैट लैंड में भी पीक्स होती हैं. एंड ये ड्रेन्स कहाँ प्रोवाइड की जाती हैं? ड्रेन्स वी शुड प्रोवाइड, ये मेरे हाथ देखो, इन वैलीज जहाँ पे नेचुरली पानी स्लोप उधर जा रहा है. All right. So canals are usually provided over the ridges in the area where our drains are usually provided in the valleys. Number one. Number two, इनका जो full supply level होता है वो कहाँ होता है? Above the adjacent ground. इनका जो full supply level है of the drain वो कहाँ होगा? किधर होना चाहिए?
Below surface.
Much below the ground surface. Not only ground surface, जो water table है उससे भी नीचे जाना चाहिए. So this is the ground water table. पहले ये ground water table इधर थी. You know, before this drain. जब ये हमने drain बना ली, the water table has come down. कुछ अरसे बाद ये कहाँ जाएगी? It may come here, and then it may further come here. So what is the use of these drains? ये सेम नालों का क्या काम है? They do the surface drainage, and also they lower down the water table. तो जब वाटर टेबल नीचे आती है तो क्या होता है?
Waterlogging नहीं होती.
Yes, तो वही जो लैंड है वो पहले जो वाटरलॉग थी अब वाटरलॉग नहीं रहेगी. So what are the surface drains? These are basically open ditches, field drains और land grading provide की हुई है. और कुछ और structures हैं वो हम discuss करेंगे कौन सी हैं. So these open drains which are used to remove water from excess irrigated area and storm water. ये जो rainfall का पानी है वो भी ये ले जाएंगे. Are broad and shallow. ये दो किस्म की हैं. एक broad drains हैं और दूसरी shallow drains हैं. और दोनों को हम कहते हैं सरफेस ड्रेन्स. शैलो ड्रेन्स कौन सी होंगी? जो प्राइमरी ड्रेन्स होंगी वो शैलो होंगी. उसके बाद जो जिसमें ये गिरेंगी वो ड्रेन बड़ी होगी. that is called as broad drain. लैंड ग्रेडिंग इंक्लूड कंटिन्यूस लैंड स्लोप. तो ये स्लोप देंगे हम, स्लोप किस लिए देंगे, ताकि अगर बारिश हो तो पानी उधर चला जाए. टूवर्ड्स फील्ड ड्रेन्स, शैलो ड्रेन्स, शैलो सरफेस ड्रेन्स आर ट्रेपेजॉइडल इन क्रॉस सेक्शन. ट्रेपेजॉइडल है जैसे कैनाल का सेक्शन होता है, एंड कंस्ट्रक्टेड टू कैरी नॉर्मल स्टॉर्म वाटर. ये शैलो ड्रेन्स हैं. दे कन्वे वाटर टू डीप सरफेस ड्रेन्स. Deep surface drains are constructed to carry storm water plus excess irrigated water from shallow drains or tile drains. अभी tile drain हमने नहीं पढ़ा. Okay, so the जो deep surface drains हैं, they receive water from the shallow drains. Number 2 is the subsurface or tile drainage. What is subsurface drainage? Why do we require subsurface drainage? जब हमने surface drainage provide कर दी है, तो there are certain areas where the soil is so impermeable that that the surface drainage doesn't work very well. So these are used for soils with poor internal drainage and there is a high water table. So water tile drain, these are pipe drains which are provided under some level below the surface, and these are made of porous ether material which are circular in cross section. तो pipeline हम बिछा देते हैं. Those pipes are connected with the main pipe and that drains into the main drain. Diameter in pipes का होता है 10 से 30 centimeter. How much 10 centimeter means? It is about 4 inches, and 30 centimeter means 1 foot. 4 inch से 1 foot. These drains laid below ground level. Ground level के नीचे होंगी. And connected with each other by open joints. इनमें ये open joints हम रखते हैं, and we provide a filter material around it ताकि जब पानी आए तो इसके अंदर चला जाए, और इनका एक slope है जिसकी वजह से the water moves. Construction of subsurface drainage is given below. Number 1 is the envelope filter. तो हम इसमें एक filter भी देंगे. The trenches which are backfilled with sand and excavated material. So when tile drains are situated below less permeable strata, then they are surrounded by graded gravels called envelope filter. Filter हम देते हैं, जैसे हम पहले coarse particle फिर small and then small. It prevents inflow of soil into the drain and increases effective tile diameter. So these are the inlets. So this is the subsurface drain. And this is the inlet for the subsurface drain, because this soil is relatively impermeable and the water directly cannot infiltrate much. And from here we provide here a envelope filter, and the water then enters in this pipe and then in the subsurface drain. This is the surface inlet. So this is called as inlet. This structure is surface inlet, draining the surface water into tile drain. And here you can see that this is another arrangement in which the ground level is lowered here, and then a depression is formed here. And here there is some the coarse material, and when there is rainfall or irrigation, and some water comes here and then it infiltrates here, and this is the soil filling, and this one is the tile drain, and with open joints, so water comes here, and this is the bottom of the trench, and this is called as French drain, and this inlet is called as blind inlet. So this was also an inlet, and this is called as surface inlet with pipe, vertical pipe. And this is the blind inlet, just material is provided and the water reaches here. And these are also some inlets like this. This is sand or excavated material, and then the water infiltrates here and then goes in this drain. And same is the case here. So this is the backfilled with excavated earth, and then this is some coarser material and further coarser filter, and then the water comes here and ultimately reaches here. So what it does, it lowers the water table. So the also from here the water comes in this direction. Outlets for tile drains. Now, as I mentioned you, there is a network of tile drain. So primary drains are like this. They are connecting with a main drain, a tile drain. Tile drain means it's a pipe of the bigger diameter, and then would have certain slope, and that main tile drain, it may fall in an open drain, which is maybe a deep drain, as we discussed, a surface drain. And the water from tile drain is discharged into some bigger drain, okay, called surface drains. The water from drain may be discharged by gravity or by pumping. It depends on what? It depends that what is the level of the outfall of the main tile drain. If it is lower than the water surface in the drain, then of course we can provide gravity outlet. And if our outfall point of the tile drain level is lower than the water surface in the surface drain, then we have to provide pump outlet. So these are the two figures. Like you see, this is our main tile drain which is coming, और इसमें ये laterals लगे हुए थे in these directions. And so if you will see the bottom of this tile drain means pipe drain, and is above than the full supply level of the main drain, our surface drain. And this is the full supply level, and this is higher. So through gravity we can provide this outlet. So this is called gravity outlet for tile drain. But if the level of the outlet is below than the bed level of the drainage, so this is a drainage, or this is called as the same nala, or the surface drain. The bed of the surface drain is higher as compared to the inward level. This is the inward level of the tile drain. Then what we have to provide? Then we have to provide a pump here. Okay, this may be a pump, and this is a vertical pipe, and this is the stop level of the pump. And there would be, this is the start level of the pump. When the water level will reach here, the pump will automatically start and lift the water, and through here it will be discharged. This is the discharging point into the surface drain. And when the water level reaches at this level, the pump automatically stops unless more water comes from the tile drain. And this difference in level is called as sump storage. Okay, so is it clear? The gravity inlet and the pump, sorry, gravity outlet and pump outlet. Do you have any questions?
सर इन पाइप की स्पेसिंग क्या रखते हैं हम सर ग्राउंड में जो?
Very good. Well, that we are discussing in this slide. Next slide में वही डिस्कस करना है, स्पेसिंग ऑफ क्या टॉपिक?
टाइल ड्रेन्स.
Spacing of tile drain, बड़ा ही timely the topic has arrived. So that we would like to discuss, and if we can take some rest, तो वो ना कर लें 10 minute, then we will start it. Huh? Shall we stop for 10 minutes?
Yes, sir.
10 minutes. क्यों जी 10 मिनट हो गए? Are you back? क्यों जी शुरू करें?
सर अभी वैसे 7 मिनट हुए हैं, बाकी आपकी मर्जी।
7 मिनट हुए? चलें। Okay ji, now I think 10 minutes are over. क्यों भाई?
Yes, sir.
जी
Okay, and now we want to discuss the topic about which the question was asked, that what should be the spacing of tile drains. ये जो pipes हैं ये हम कितने कितने करीब किस spacing से लगाएं. The spacing usually varies from 50 to 150 feet, and these are for the ये lateral जो tile drains है उनकी है, और main drain maybe main tile drain or pipe, a bigger diameter pipe may be in the central position. So these are the drains, tile drains. और ये यहाँ पे हम pipes provide करेंगे with open joints with some filter material. So when you will provide these drains, then what will happen? The water table might be, it was here close to the ground. Due to these tile drains, water table may come down like this. So this may be the parabolic water table profile, and the water table is lowered up to this level. This is assume that this is some impermeable layer, and if these tile drains are provided at a distance of small a with respect to this impermeable layer, then this rise, there would be slightly this rise, and the distance from the impermeable layer to the peak of the water table profile is called as B. So A and B are these vertical distances, and Y is a distance at any distance X from this tile drain. But anyway, the simplified equation to compute the spacing of the tile drainage is given as 4K B square minus A square over Q, where Q is the discharge of discharging capacity of these tile drains, and K is the hydraulic conductivity of this material, porous material, and B, as I discussed this, the vertical distance from the impermeable layer to the peak of the water table, and A is the vertical distance from the the impermeable layer to the center of the this tile drain. So using this equation, one can compute spacing. And now on this, there is one numerical, which is example 12.1. So a farmer plans the installation of tile drains in a field in which the soil permeability is this much. This is the coefficient of permeability, 500 gallons per day per square feet. So this is per unit area. An impermeable stratum exists about 10 feet below the soil surface. So this is the soil surface, and this distance is 10 feet. And the ground level is desired at least, and groundwater level is desired at least 3 feet below the soil surface. And now what the farmer wants, that this water table should go down at least 3 meter, is it meter feet? 3 feet, 3 feet below the ground surface. So this is the ground surface, and he wanted that the water table should go 3 feet below it. So it means the peak apex of this water table should lower down by 3 feet. So if this is the 3 feet, and now what we can assume that this central rise of the parabola is 1 foot, and accordingly we can compute the A and B. So if this is total is 10 feet, and this farmer wants that it should be lowered by 3 feet, then what is the value of B? How much should be value of B?
7 feet.
7 feet, yes, good. And by assuming a central rise of 1 foot, then what should be value of A?
6.
6 feet, yes. So that he has computed, the A is 6 feet and B is 7 feet by assuming 1 foot rise. Now the K, hydraulic conductivity, is given as 500 gallons per day per square feet, and you know that 1 gallon per day is 0.134 cubic feet per day, or we know that 1 cubic feet is 7.46 gallons, whatever the relation you want to use. Anyway, the K was converted to in units of feet per hour. We know that the coefficient of permeability is you have units of length over time. So 2.79 feet per hour. Now the Q is the total discharge per unit length of pipe. So it is also given 0.05 cubic feet per hour into square feet. So multiply by L, which is the spacing. Okay, and so this drain receives water from this much length, which is equal to spacing of the drain. Hence, simply after simplification, it becomes 0.05 L cubic feet per hour, and then putting in this equation, L is equal to K4, K is this much. These are the A square and B square, B square and A square values, and the 0.05 L. So the L becomes a square, and if you will take under root, the L will come 53.8, roughly means 55 feet. So this is how you can design the spacing of the tile drains. You have computed as 55 feet. A normal range is 50 to 150 feet, center to center. So this is the role of tile drains. What is the main purpose of tile drains? क्योंकि क्या purpose है? You know, initially the water table, maybe it was here. And due to this tile drains, now the water table where has gone? कहाँ चला गया है? Now this is the water table. नीचे आ गया ना ये वाला, है ना? This is the, sorry, this is the water. This is the water table. तो अब ये नीचे आ गया है काफी. इतना water table has gone down. All right. So this is the role of tile drains. Now we have to discuss the layout of tile drains. Layout कैसे होता है? Tile drains are aligned in different ways depending upon topography of the area. Layout किस पे depend कर रहा है? On the topography of the area. So here general layout of tile drain network. ये main drain है, main tile drain है, and you know these are one. Where is 2? This is 2. This is 3. This is 4. This is 5. These are the tile drains. Spacing हमने इनकी निकाली है ना? This spacing है 50 to 150 feet. And these are called as lateral tile drains. And this is the main tile drain. ये कहाँ जाएगी, किस में गिरेगी? It will fall in an open drain. और open drain फिर मजीद जो main open deep drain है उसमें fall कर सकती है. Now, various types of layout of tile drains, which are basically based on the topography of the area, are these 5. Number 1, natural system. Number 2, gridiron system. Number 3, herringbone system. Number 4, double main system. And number 5, intercepting tile drains. So that we would like to discuss. So this is the natural system. So what is this system is adopted in rolling topography, upper rise है, where drainage of isolated areas is required. So if you will see the contour map of this area, it is like that. And you know, once we have these such type of places where there are these sharp curves are formed, तो यहाँ क्या होता है in the contour map? Okay, in the contour map, if we have like this, तो ये कौन सी जगह होती है? हाँ जी, if in contour lines we have the sharp curves like these, तो what they indicate? क्या indicate कर रहे हैं? हिली तो एरिया है, मतलब ये क्या इंडिकेट करेगा? Either this will indicate
ridges and valleys.
Yes, या वैली को ये शो करेगा या रिजेस को शो करेगा. Now how I can know that कि ये रिज को शो कर रहा है या वैली को शो कर रहा है? You know how much here is the elevation? कितना elevation है? ये कंटूर 222. ये कंटूर कितने का है?
220.
220. So it means यहाँ पे लेवल मेरा कितना है? 222 और यहाँ पे लेवल कितना है? 220. तो ये क्या है? ये रिज है या वैली है? वैली. दिस इज ए वैली. ठीक है ना? यहाँ पे लेवल कम है, यहाँ लेवल ज्यादा है. सो दिस इज ए वैली. सो सच टाइप शोज दी वैलीज. तो ये भी वैली है, ये भी वैली है, ये भी वैली है, ये भी एक वैली है, ये भी वैली है. तो जस्ट प्रोवाइडिंग टाइल ड्रेनेज या सब सरफेस ड्रेन्स अंडर दी वैलीज. ये वैलीज के नीचे में है. तो इसको क्या कहते हैं इस सिस्टम को? दिस इज द नेचुरल सिस्टम. भाई पानी ने, सरफेस वाटर ने वहीं वैली में जाना है. वैली के नीचे वी आर प्रोवाइडिंग टाइल ड्रेनेज. So this pattern of the tile drainage is called as a natural system. Means adopting the natural topography of the area. जहाँ पर वैलीज हैं उसके नीचे हम टाइल ड्रेन प्रोवाइड कर रहे हैं. The second is grid iron system. In this system, laterals are provided only on one side of the main drain. ये main drain है, which is tile drain, और सिर्फ एक ही तरफ हम टाइल ड्रेन्स प्रोवाइड कर रहे हैं या लेटरल्स प्रोवाइड कर रहे हैं, विच आर दीज. एंड इट इज अडॉप्टेड व्हेन द लैंड इज प्रैक्टिकली लेवल लैंड है. तो ये यू कैन सी दैट दीज आर द कंटूर्स. तो ये ऊंची जगह है, 224 है, यहाँ पे 214 है लेवल. सो इस पॉइंट का लेवल ज़्यादा है, इसका कम है. सो वाटर हैज़ टू फ्लो इन दिस डायरेक्शन. एंड यहाँ से ये टाइल ड्रेन्स इसमें यूँ पानी फेंक रही हैं और फिर यहाँ से यूं जाएगा. तो दिस इज कॉल्ड एज ग्रिड आयरन सिस्टम. ओके. द नेक्स्ट इज herringbone system. Herringbone. In this system, laterals join the main from each side alternatively. ये main tile drain है. And let's say this is the one lateral, this is the second lateral from the other side, this is the one lateral from this side, then this lateral. Alternately the laterals are from right and left, and this is called as herringbone system. अच्छा, इसमें ये जो कंटूर्स आपको दिखाए हुए हैं, सो ये 222 का है और ये 220 है. सो व्हाट इट शोज, ये कौन सी जगह है? वैली है या पीक है इन द एरिया?
वैली है सर.
दिस इज वैली. तो हमने मेन जो है ये वैली पे डाल दी, और ये जो लेटरल्स हैं ये हमने दोनों तरफ से अल्टरनेटिवली अप्लाई किए हैं, फिक्स किए हैं. सो दैट्स व्हाई इट इज कॉल्ड एज herringbone system. ओके. नाउ द नेक्स्ट इज डबल मेन सिस्टम. अच्छा, अब कोई वैली बड़ी चौड़ी होती है. सो वैली इज वेरी वाइड. So in that wide valleys, so we may provide two main tile drainage. तो ये दो मेन्स हमने प्रोवाइड कर दी, और इधर से ये हमने लेटरल्स प्रोवाइड कर दिए. इधर से एक तरफ से लेटरल है. तो इसमें लेटरल कितनी तरफ से होंगे? ओनली फ्रॉम वन साइड. एक मेन जो टाइल ड्रेन है, इट विल रिसीव लेटरल्स फ्रॉम वन साइड, मे बी लेफ्ट साइड, एंड दिस मेन टाइल ड्रेन विल रिसीव लेटरल tile drains from right side. So it has two mains. इसमें दो main है with separate laterals for each main. It is adopted when bottom of depression is wide. ये बहुत wide है, ठीक है ना? Valley बहुत wide है. That's why we are providing two main, and this is called as a double main system. Is it okay? Clear? The next is intercepting tile drain. The word of intercepting we are using again and again. And if you will see these contours, तो ये क्या शो कर रहे हैं? ये सबसे ऊंची जगह है भाई, है ना? ये नीची जगह है, ये उससे नीची, ये उससे नीची. तो ये क्या है? ये हिल स्लोप है. दिस इज लाइक दिस इज ए हिल स्लोप, है ना? अब हमने क्या किया है कि जहां पर एट द टो ऑफ द स्लोप वी हैव गिवन ए ड्रेन. यहाँ पे हमने एक ड्रेन दे दी है, एंड दिस ड्रेन इज कॉल्ड एज इंटरसेप्टिंग ड्रेन. So in this system there is no lateral drain. Lateral drain नहीं देनी, बस surface से पानी यहाँ पे gravity से आएगा, maybe due to rainfall, and it will be intercepted by this drain. A main is provided at toe of the slope. ये main है, and it is adopted when main source of drainage is from hilly land. पानी आता ही हिली एरिया से है, उसको रोकने के लिए, उसको इंटरसेप्ट करने के लिए we have given the intercepting drain. Is it clear? क्यों जी? तो हम ये कौन सी टाइल ड्रेनेज पढ़ रहे हैं ना, ये टाइल ड्रेन में इंटरसेप्टिंग ड्रेन है, बट इंटरसेप्टिंग ड्रेन कुड बी ए सरफेस ड्रेन, ये ओपन भी हो सकती है, लेकिन चूंकि हम ये पढ़ रहे हैं टाइल ड्रेन्स में, तो ये भी टाइल ड्रेन ही है, इंटरसेप्टिंग टाइल ड्रेन. ओके, नाउ द ड्रेनेज वी हैव कवर्ड फुल्ली. ड्रेनेज की दोनों किस्में पढ़ ली, एक सरफेस ड्रेनेज और दूसरा सब सरफेस ड्रेनेज. ये दोनों ड्रेनेज जो हैं दीज आर कॉल्ड एज हॉरिजॉन्टल ड्रेनेज, और एक है वर्टिकल ड्रेनेज. वर्टिकल ड्रेनेज मींस बाय पंपिंग, बाय लिफ्ट इरिगेशन. अच्छा जी, आफ्टर ड्रेनेज नाउ we would like to discuss the salinity. Salinity is the concentration of dissolved salts found in water, that is called as salinity. It is measured as the total amount of dissolved salt in part per thousand, sometimes called PSU, practical salinity units, by certain scientists. 10 parts per thousand is equal to 1%. 10 over 1000 means 1 over 100. So 1%. All right. So that is salinity. Concentration of dissolved salts, if those are in water, that is called as salinity. Injurious salts are alkali salts. Alkali salts ज़्यादा नुकसानदेह हैं. वो कौन से हैं? सोडियम क्लोराइड. What is sodium chloride? वो क्या होता है?
साल्ट जो यूज करते हैं,
जो हम खाते हैं, है ना? सोडियम सल्फेट. एंड थर्ड इज सोडियम कार्बोनेट. ये क्या चीज है सोडियम कार्बोनेट? ये भी बड़ा यूज करते हैं आप.
कास्टिक सोडा सर, क्लीनिंग पर्पस के लिए यूज करते हैं, वो तो नहीं है?
जी, कास्टिक सोडा. ये जो सोडियम कार्बोनेट है ना, दिस इज द मोस्ट हार्मफुल. किधर गया है? दिस इज द मोस्ट हार्मफुल. दिस वन, सोडियम कार्बोनेट, कास्टिक सोडा, सबसे हार्मफुल जो है एग्रीकल्चरल सॉइल के लिए कौन सा साल्ट है? कास्टिक सोडा, सोडियम कार्बोनेट. और जो ये सोडियम क्लोराइड है, दिस इज द लीस्ट हार्मफुल. बहरहाल ये सारे जो सॉल्ट्स हैं दीज आर सॉल्युबल इन वाटर. इन सॉइल्स साल्ट मूव्स विद वाटर. पानी के साथ, चूंकि जो कैपिलरी राइज है पानी ऊपर जाता है, वाटर टेबल चूंकि ऊपर है, कैपिलरी राइज से पानी ऊपर जाएगा, तो साल्ट भी ऊपर जाएंगे. इन waterlogged soils, salt appears on the surface with water due to capillary action. Capillary action से ऊपर आ जाएगा salt. Water gets evaporated. जब पानी evaporate होगा, maybe when there is too much the sunlight or solar radiation, तो leaving a layer of salt on the surface. अब surface के ऊपर salt की layer आ जाएगी. वो कहाँ से आई है? वो कैपिलरी एक्शन से पानी ऊपर आया, water evaporate हो गया और salt. How much is the thickness of this salt? 5 to 7.5 centimeter. 5 सेंटीमीटर से 7.5 सेंटीमीटर. 5 सेंटीमीटर का क्या मतलब है? 2 इंच. 2 इंच से 3 इंच. 2 से 3 इंच की लेयर बन जाएगी वाइटी साल्टिश मटेरियल. और उसको हम क्या कहते हैं? ये जो ज़मीनों पे आ जाती है सैलिनिटी, और जो साल्ट आ जाता है, इन इंग्लिश वी कॉल इट एफ्लोरेसेंस. ये जो वाइट सरफेस बन जाता है, दिस इज कॉल्ड एज एफ्लोरेसेंस. तो इन दिस चैप्टर आप क्या क्या डिस्कस कर रहे हैं? वाटर लॉगिंग एंड सैलिनिटी, है ना? तो इसको उर्दू में क्या कहते हैं? वाटर लॉगिंग एंड सैलिनिटी को व्हाट वी कॉल इन उर्दू? हाँ जी,
सेमोथोर।
सेम और थोर. So same means waterlogged land और thor means saline land. Saline वहाँ पे salt surface पे नजर आ रहा है. Alright? So ये same और thor है. और thor की वजह क्या है? Waterlogging. Waterlogging की वजह से water table has gone up and ऊपर surface पे मजीद capillary rise है, वो पानी surface पे आएगा और चूँकि वो पानी में salts हैं, but those salts पानी जो है इवेपोरेट हो जाएगा, साल्ट्स वहीं रह जाएंगे and the salts you can see and that is called as efflorescence. The figure of efflorescence is this. ये नजर आ रहा है salt? क्यों भाई? This is the salt on the surface. This is ये और मोटी thickness है of the salts here and this is called as efflorescence. What is the primary man-made cause of salinity? Salinity का cause क्या है? क्यों होती है salinity? क्यों जी? That is the क्या वजह है? Over irrigation. बहुत ज़्यादा पानी लगाएंगे तो वाटर लॉगिंग होगी, वाटर लॉगिंग होगी तो फिर salinity होगी. हाँ? River water or groundwater used in irrigation contains salts. अगर ग्राउंड का पानी ले रहे हैं वो खारी है, उसमें साल्ट है, या अगर हम रिवर से ले रहे हैं पानी तो साल्ट उसमें भी तो है ना. तो which remains in soil after the water has evaporated, तो वो नजर आएंगे हमें. And this is the salinity and these lands are called as saline lands या salt affected lands and Urdu we call थोर ज़दा ज़मीनें. ठीक है? This is saline seepage area. This is a high area and this is a low-lying area. If there is a rainfall here and there are salts here, तो ये सारे जो salt हैं वो पानी के साथ, यहाँ पे salty कोई material पड़ा हुआ है, then this water becomes saline और वो मूव कर रहा है डाउन और वो यहाँ से इमर्ज करेगा और यहाँ पर दिस एरिया विल बिकम साल्ट अफेक्टेड एरिया और saline एरिया. नाउ द क्वेश्चन इज हाउ वी कैन कंट्रोल salinity. भाई वाटर लॉगिंग को कैसे कंट्रोल करेंगे? Our chapter is waterlogging and salinity. हमने देखा waterlogging और salinity is causing a lot of problems on agricultural lands. तो waterlogging को भी हमें चाहिए, we should know how we can reduce waterlogging and similarly how we can reduce salinity. So or how we can control waterlogging and salinity. तो वो कैसे करेंगे? Waterlogging कैसे कंट्रोल करते हैं? By providing efficient drainage. सरफेस ड्रेनेज एंड सबसरफेस ड्रेनेज. और दूसरा क्या है कि इरिगेशन में बहुत ओवर इरिगेशन नहीं करनी. ठीक है? नाउ दिस सैलिनिटी कंट्रोल, मेन पर्पस क्या है सैलिनिटी कंट्रोल का? टू प्रिवेंट सॉइल डिग्रेडेशन बाय सैलिनेशन एंड रिक्लेम साल्टी सॉइल्स. अब साल्टी सॉइल को हम बनाना चाहते हैं, रिक्लेम करना चाहते हैं, यूजेबल फॉर्म में लाना चाह रहे हैं, तो उसको हम कहते हैं रिक्लेमेशन ऑफ लैंड. सो सॉइल रिक्लेमेशन इज आल्सो कॉल्ड सॉइल इंप्रूवमेंट, जिसको रिहेबिलिटेशन भी कहते हैं, रेमिडिएशन भी कहते हैं और रिकूपरेशन भी कहते हैं. इट रिक्वायर्स दो चीज़ें चाहिए जी. पहले तो जो कॉज है ऑफ सैलिनिटी दैट वाज वाटर लॉगिंग, उसका कंट्रोल करें. वो कैसे करेंगे? बाय एफिशिएंट ड्रेनेज. And you know efficient drainage we have already studied by providing surface drains and by providing subsurface drain. Once we have provided that, then the second step we have to do is the leaching. So leaching is a method, primary method of controlling soil salinity. कैसे? bypassing or by permitting 10 to 20% of irrigation water to leach the soil. वो पानी हम पास करेंगे soil से and it will move through the tile drainage and it will be disposed of from that land and be drained and discharged through an appropriate drainage system. तो वो extra पानी जो है हम 10 to 20% of the irrigation water वो चलाएंगे ताकि वो, this is called as leaching. The salt concentration of the drainage water is normally 5 to 10 times higher than that of irrigation water. अब जब हम ड्रेन करेंगे तो उसकी साल्ट कंसंट्रेशन बहुत बढ़ जाएगी जो पानी टाइल ड्रेनेज में जाएगा एज कम्पेयर टू जो हम इरिगेशन वाटर दे रहे हैं. Thus salt export not matches salt import and thus it is removed. जो साल्ट बाहर निकल रहे हैं वो ज़्यादा होंगे थ्रू टाइल ड्रेनेज सिस्टम, जो आ रहे हैं वो कम होंगे. सो इन दैट वे दिस टोटल साल्ट्स जो हैं वो कम हो जाएंगे इन दी saline soil. When sodium carbonate is present in saline soil, हम जिप्सम यूज कर सकते हैं. और ये सोडियम कार्बोनेट क्या है भाई? व्हाट इज सोडियम कार्बोनेट?
कास्टिक सोडा.
कास्टिक सोडा. जब कास्टिक सोडा है और ये सोडियम कार्बोनेट लेस हार्मफुल है या मोर हार्मफुल है फॉर क्रॉप्स? मोस्ट हार्मफुल. उस वो अगर हो जमीनों में तो वी कैन यूज जिप्सम विच इज कैल्शियम सल्फेट. Is generally added to the soil before leaching by mixing with water. वो हम पानी में मिक्स करके और फिर वो लगाएंगे तो ये जो सोडियम कार्बोनेट है रिएक्ट करता है with कैल्शियम सल्फेट and it forms sodium sulfate which can be leached out. वो पानी से निकल जाएगा. Alright. So this is the how we can control the salinity. तो जी salinity को कैसे कंट्रोल करेंगे? By two steps. Number one, by providing proper efficient drainage. और drainage में surface और subsurface drainage दोनों. And दूसरा कौन सा step है? We have to do the leaching. Leaching means we will supply extra irrigation water through the soil. वो क्या करेगा? वो जो salts हैं उनको move कराएगा in downstream direction, which will, and then they will enter into the tile drains and then will be removed in the main drain. ठीक है? So that is the leaching process. And now the scarp. Have you ever heard word scarp? Scarp सुना है? Scarp was a department perhaps of WAPDA, and that stands for Salinity Control and Reclamation Project. So it worked for a long time in Pakistan, in our provinces, Sindh, Punjab, KP, and where there was waterlogging and salinity problem. इनका काम क्या था? To provide the drainage, surface drainage and subsurface drainage, to lower the water table. waterlogging को ख़त्म करना था और दूसरा salinity को कंट्रोल करना था. तो salinity control by leaching and by other means, maybe by lift irrigation, by providing tube wells. तो tube well का क्या मकसद है? To lower down the water table. So that was the main purpose of this department and this project. That is the SCARP. And with this, we have finished this chapter. Now, if you have any questions, you are welcome. जी भाई.
सर ये आप गवर्नमेंट की तरफ से ड्रेनेज प्रोवाइड करता था या किसानों के खर्चे पे?
नहीं ये दिस वाज अ गवर्नमेंट डिपार्टमेंट. वापडा का सब्सिडी थी स्कार्प एंड दे हैव प्रोवाइड ड्रेनेज, सरफेस ड्रेनेज एंड सब सरफेस. ये जो सेम नाले शाले बने हैं ये इन्होंने स्कार्प ने बनाए हैं. जो इरिगेशन कैनाल्स हैं वो किसने बनाई हैं? irrigation department. Yes. So, do you have any more questions? क्यों जी? क्यों जी? तो वाटर लॉगिंग का मेन व्हाट इज द मेन कॉज ऑफ वाटर लॉगिंग? क्यों होती है वाटर लॉगिंग?
वाटर टेबल राइज करने से रूट जोन में आ
किससे?
जाते हैं।
हैं? What is the main cause of water logging?
इरिगेशन।
ओवर इरिगेशन, जरूरत से ज्यादा पानी देने से, है ना?
यस सर।
और इरिगेशन तो हम कर रहे हैं और ड्रेनेज नहीं है, तो जो पानी हम सप्लाई करेंगे वो तो अंदर ही जाता रहेगा ना ग्राउंड के, उससे क्या होगा? वाटर टेबल राइज होगा. सो दैट कॉजेज द वाटर लॉगिंग. ऑलराइट. So whenever we have to start an irrigation project in which by artificial means we are providing water, तो फिर साथ ही हमें ड्रेनेज प्रोजेक्ट भी बनाना चाहिए ताकि जो एक्सेस वाटर है which we are supplying to the agricultural lands, it may be taken away by that surface drains and subsurface drains. तो फिर वाटर लॉगिंग नहीं होगी. जब वाटर लॉगिंग नहीं होगी तो सैलिनिटी होगी? There won't be salinity. And with this, the chapter is over.
तो सैलिनिटी
सर
और
लीच
फ्लोरिड
का क्या मतलब है?
हाँ जी.
तो
सर लीच
सैलिनिटी
का
और
मतलब
फ्लोरिड
क्या है?
में क्या फर्क?
एक at a time. I think one by one जी. कोई एक बोल ले.
सर इधर लिखा हुआ था लीच करना, तो लीच का मतलब क्या होता है?
लीच. लीच का क्या मतलब लग रहा है? लीच का मतलब ये है कि पानी से हम किसी चीज को धो रहे हैं. जब हम सॉइल के अंदर से पानी पास करेंगे तो जो साल्ट लगे हुए हैं दोज विल बी रिमूव, जो डिजोल्व सॉलिड्स हैं. ठीक है ना? दैट इज मीन्स लीच और लीचिंग.
तो सर सैलिनिटी एंड फ्लोरेसेंस में क्या फर्क है?
नहीं, सैलिनिटी तो बेसिकली इज आई थिंक कि एक जस्ट जो कंसंट्रेशन साल्ट्स की है ना, दैट इज कॉल्ड एज सैलिनिटी. सैलिनिटी मीन्स कि वो तो सॉइल के अंदर भी है, विच इज नॉट ऑन द सरफेस. फॉर एग्जांपल अगर हम नीचे चले जाते हैं सॉइल के और वहाँ पर भी डिजोल्व साल्ट्स अवेलेबल हैं तो वो लैंड भी सेलाइन है. Efflorescence is only this layer of salt which appears on the surface. तो वो efflorescence है. Efflorescence is an indication कि जनाब ये जो लैंड है ये कौन सी है? सेलाइन है ना? This land is a saline land. Okay.
यस सर.
So if we want to reduce the salinity, तो फिर हम क्या करेंगे? If that efflorescence, if it has a considerable thickness like 2 inches or 3 inches, तो that पहले तो उसको remove करें and tile drainage provide करें. Okay, and then do the leaching. तो वो काफ़ी बेहतर हो जाएगी. Its salinity would reduce. Okay, now we have only one chapter left, and that is the wells. So that I plan के कोई 2 hours का वो एक लेक्चर ले लेंगे in your psychomotor week, ठीक है? Maybe the first psychomotor week or second psychomotor week, and the next week are your exams, inshallah, and do well preparation, and wish you best of luck. तो ये मैं शेयर कर लेता हूँ आपसे this chapter. So any more questions? Otherwise we would like to stop today.
सर ये मिड स्लाइड थे सर, अगर वो दोबारा भेज दें व्हाट्सएप ग्रुप में सारे।
क्या भेज दूं?
सर मिड्स के जितनी भी स्लाइड्स है सर, आपका जो जितना भी कोर्स है
वो वैसे मैंने सारा दिया हुआ है पहले।
सर। वो असल में बहुत सारे फाइल्स में सारे मिक्स हो जाते हैं तो बड़ा मुश्किल से अरेंज होता है फिर।
चलें दोबारा भेज देते हैं, वो हमें क्या है।
यस सर, जितनी भी मिड्स की सर फाइल्स है। थैंक यू सर।
ओके जी, अल्लाह हाफिज।
अल्लाह हाफिज़ सर।
अस्सलाम वालेकुम।
वालेकुम अस्सलाम।